Symmetric difference, an overview. Given sets X and Y, the symmetric difference of the sets is denoted in this way. This is defined as the set X minus Y union Y minus X. So we are taking a difference between X and Y in two ways, which makes it symmetric with respect to X and Y. It's good to think of the symmetric difference of X and Y as the set consisting of those U that U is in X maybe I should say either U is in X or U is in Y. So here the logical operation used is that of the exclusive OR, either or, in X or in Y, but not in both. And in a diagram, the symmetric difference would be the shaded area. Here's an example, the set with 1 and 2, symmetric difference, the set with 2 and 3, equals to the set with 1 and 3. Indeed, 1 belongs to the first set and not the second. 3 belongs to the second set and not the first. 2 doesn't go into the result because it belongs to both sets, and the common part needs to be excluded. Here is a fact concerning the symmetric difference. Symmetric difference of X and Y can be also viewed as the union of the two sets from which the intersection has been excluded. Please compare this with the previous diagram. The union of the two sets from which the white area of the intersection has been excluded. And another fact useful in proofs concerning the symmetric difference, Z is a member of the symmetric difference of X and Y, if and only if Z is a member of the union and not a member of the intersection. Also, Z is not a member of the symmetric difference of X and Y if it is not a member of the union or it is a member of the intersection. We mentioned previously possible implementations of sets on a computer. The first being implementing sets as dynamic hash tables, and the second implementing them as bit vectors with logical bit operations. And at this point, let us notice that the symmetric difference can be incorporated into such implementations. We already know that symmetric difference is defined in this way, so once we have the union and set difference in the implementation, it is immediate to add symmetric difference. Also, for bit array implementations, please notice that the programming language often provides a bitwise exclusive OR operation denoted by this symbol, and this can be used as an implementation of the symmetric difference. Indeed, Z is a member of the symmetric difference if either it is a member of the first set or the second set. The logical operation here is exclusive OR, so exclusive OR bitwise operation is a perfect match. And some exercises. Find the values of these expressions. Also complete the following. Making diagrams may help in finding the answer. And a somewhat more challenging exercise, characterize the inclusion X is a subset of Y in terms of symmetric difference of X and Y. And also variants where X or Y are complemented.